So I gave you that yellow sheet. You want it out, or at least one per table, so that you can kind of glance at it. What I want to try and do, I kid you not, Mateo, is actually train your eyes where to glance on this sheet. You don't memorize things, but your eyes will actually start to remember. When your brain says, where was, your eyes will glance in the right place automatically. And that's just a good time saver. I don't like it when kids have to hunt everywhere for it. So one of the things you're going to hear me saying all the time, where is that on your sheet? And what I'm really trying to teach you to do is glance at, oh, there it is, and your eyes will actually remember where to look. It's me being really, really fussy, but it's handy. We said this, V equals I times R, where V was voltage, I was current, and R was resistance. In our analogy, voltage was like how high the mountain or how high the ski hill was. Yes, my child? Let me just hit pause for a second here. Hang on. And I, current, was like, it's actually sort of like two things. It's both the number and speed of the skiers. And resistance was like how deep the snow was. We're going to flog that analogy, but for now we have it as an equation. Something equals something times something. I'd like you to imagine, suppose I said to you, 12 equals 6 times 2. And I don't have the, oh yeah, I do have this in your notes. Can you write two other true equations from this? If 12 equals 6 times 2, can you write 6 as an equation from that? It's not meant to be tough. Don't overcomplicate it. How can I use a 12 and a 2 and get 6 as an answer? Okay, so another way to write this is, could you write 2 as an equation? Here's what I want you to realize, and there is a spot in your notes for this, right? We're now, I think, right here. Rather than 12 equals 6 times 2, this is algebraic. It's V equals I times R. Can you write two other true equations from this? If 12 equals 6 times 2, which also means that 6 equals 12 over 2, what does I equal from this equation here? Very nice. Yes? Rihanna, with bold authority in your voice, say what?
V divided by R.
And what does R equal?
V over I.
Yep. It's actually 3 equations in one. Now, if you look on your formula sheet, on your yellow sheet, I gave you all 3 of them. If you ever take Physics 12, I teach my kids how to do this in their head. They remember one equation and they can rewrite it any way they want to, and it's a much better way to do it than memorizing. But can you, right now, on your yellow sheet, see if you can spot where Ohm's law is, where V equals I times R is, where I equals V over R is, and where R equals V over I is? See them there? Yes, yes, yes? Good. Stop! Write all 3 equations on the front page of your notes at the top of this page. So go to the very, very top of your notes, front page, and at the very, very top, you can write V equals IR, I equals V over R, and R equals V over I. I think so, because look, you guys are learning some equation solving right now in math, I believe. What's happening between the I and the R? Timesing. So how would I get the I by itself? I would divide by the R. Or how would I get the R by itself? I would divide by the I. It's actually equation solving. And you'll notice in each of these, Kiana, there is unos, dos, tres, eins, zwei, drei, un, deux, trois, 1, 2, 3 variables. What it means is I can give you any 2 and you can calculate the third. I can give you any two in a circuit. Anywhere in a circuit, I can tell you what the voltage is and the current is, and you can find the resistance there. Or I can tell you what the resistance is and what the voltage is, and you tell me how many amps and current is right there. Or I can tell you what the current and what the resistor is, and you can tell me what the voltage is right there. In other words, we're starting to be able to get to the point, Aiden, where we can solve circuits. What does V equals I times R mean? The blank you can fill in. If we know any two, we can calculate the third. If I know two, I know three. If I know two, I know three. If I know two of these, I know three of these. Figure out where we are? You guys good? Gonna make it? You awake? You alert? You alive? Okay, Nicole, you know where we are? Figured it out? Yes? Look over Aiden's shoulder if you're not sure. And we're gonna turn the page. No, you're not. You guys are still there. I have something I think that's underlined and bold-faced in your notes, yes? And it's also in all caps, yes? You know what all caps means on the internet? Oh, we already did this. It is really worth memorizing which units go with which quantities. All caps means shouting. And since that's all I can do with my sore throat, that worked out quite well. So, voltage is measured in volts, which is pretty easy. Current is measured in amps. Resistance is measured in ohms, ohms, ohms. Resistance is measured in ohms. Why do I say, oh, and let's use the symbols. What was the symbol for voltage? V. What was the symbol for amps? A. What was the symbol for ohms? It was not a zero. It's a mouse hole in the wall. It's a Greek letter omega. Yeah. Why don't we use an O? Because it looks like a zero. We can avoid that. Okay. Why is it worth memorizing what units go with what? Because, and this is going to terrify you, don't let it terrify you. You're going to be dealing with word problems, but they're easy because actually what you look for are numbers and units, and you know it's the current because it's got the word amps next to it. Or you know it's the voltage because it's got the letter V or the word volts next to it. Or you know it's the resistance because it's got the letter omega or ohms next to it. Turn the page. No? Join the resistance. Okay, I thought it was funny. Practice problems. You ready? In physics, I teach my students an acronym that I call DFIC. And DFIC stands for, you can write this down if you want, or you can just watch. Here's my acronym. The D stands for list your data, step 1. The F stands for find a formula, step 2. The I stands for insert or substitute values. And the C stands for crunch the numbers, crunch the answer. In fact, if you want to, do I have a, you know what, at the top, right above examples, if you want to, you can write data, formula, insert. Yeah, we turned the page. Good way to catch up with us, Rihanna. Whoops, didn't want to do that. What happened there? I went way back. Oh, I went to the previous document. That was silly. Wrong button. Data, formula, insert, and then calculate, or I usually just call it crunch the numbers because that's less work. DFIC. It's a good approach because it's nice and systematic. Also, it gets you in the habit of writing stuff down. Mitra, I've learned if kids write stuff down, they're no longer nervous, they do better. Go figure. Here's what I mean. Here's an example. The current through a light bulb is 2 amps. If the voltage is 9 volts, what is the resistance? Step 1 is list your data. I always ask, what are they asking me to find? What are they asking me to find? Amelia, what's our abbreviation? What letter, not units, what letter are we using for resistance? Capital what? Here's what I write. To show that that's what I'm trying to find, I write down R equals question mark. Do that, please. What else have they told me? I see a 2. See the 2? What is the 2? Look at the units next to it. What is the 2? Which means it's what? What letter are we using for current, capital letter? Not using C, sadly. A is the units. What? You can write amps next to it if you want to, but I usually just list it. Now, for some of you who are good at math, this may seem pretty simple. We're going to get complicated pretty quick. So this is a good method. I see a 9. What's the 9? What letter are we using? What letter are we using for voltage? Conveniently, both the unit and the symbol, okay? So then I would say to myself, I'm looking for an equation that has an R, an I, and a V in it, but it would be really nice if the R was by itself. What's the equation that has an R and an I and a V in it and has the R by itself? No, that doesn't have the R by itself, has the V by itself. Someone said V equals I times R. I want the version of that that has the R by itself. Let's write that down. Now we substitute in the values. R equals, what's V? And if you've done this, now it's plug and chug, which is the phrase that I use in physics all the time. What's V? Go look where you listed your data. If you set it up right, you can almost turn your brain off from here and it becomes very mechanical. 9, or is that a German saying no? 9? No? Okay, fine. Divided by, what's I? Rihanna just got it. What's I? 2? What is 9 over 2? You might be able to do this one in your head. 4.5. What are we finding? So R equals 4.5. 4.5 what? Now we always add the units. Resistance. Ohms. Ohms. This is going to be our approach, except we're also in a few days, I'm going to teach you how to calculate power, which is measured in watts. And we're going to actually have 4 things. And what I'm going to say is instead of if you know 2, you know 3, it's going to be if you know 2, you can find all 4. And even more than that. Let's try another one. Example. What is the resistance of a light bulb with a voltage drop of 120 volts and a current of 15 amps? What are they asking me to find here? By the way, in math, word problems suck. In physics, word problems are nice because you know what units go with what values. Aiden, what are they asking me to find? Just read the question to me. What are they asking me to find? See, it's usually pretty, if you can read it, it's pretty obvious. What's my letter that I'm using for resistance? What's my symbol? Capital. No, what letter? Capital what? R, right? I went to go see a private movie the other day. I couldn't get it in because it was rated R. 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 Okay, anyways. I always do that. I identify what I'm trying to find, Kiana. 120. Huh? What is that? Look at the units right next to it. Lena, you're right. Say it nice and loud and proud. V equals 120. What's that 15? Amps, which is what? Current. Symbol? I, not C. There's the D part of DFIC. There's listing the data. I'm looking for an equation that has R, V, and I, and it would be really nice if the R was by itself. Which one? Same as we just did. V over I. Now let's crunch. What's the voltage?
120.
120. And Kiana, what's I? What's the current? It's reading right there. Right here. Yeah, say it with authority and pride in your voice. 15. Okay, this one you may or may not be able to do in your head. If not, use a calculator. By the way, I will not try and make these work out evenly. It's a lot of work to try and do that, and I love you, but not that much. Sorry? 8 even? 8. 8 what? Ohms. On your test, you can expect several of these. In fact, if I do my job right, you'll be doing most of these bored, like, oh, free marks, if I do my job right. Here's another one. I think for you guys, you guys are moving down on your paper, but I wanted to fit both of these on the same sheet. Okay. Hey, what are they asking me to find in this one? What is the? Oh, current. I equals question mark. Now I scan the question for numbers. What's the first number that you see? What is that 18? Look at the units. Ohms. So what is that? R equals 18. Right? Keep scanning. Hudson, what's the next number you see?
Oh,
6. What are the units next to the 6? Oh, are you saying that this is the voltage? Sure. I'm looking for an equation that has I, V, and R, but please let it have the I by itself. It's also on your formula sheet somewhere.
I equals V.
I equals V over R. What's V? What's R?
18.
What do you get? 0.33333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333. Okay. Units, current. A, which stands for the word amps. I'm not big on memorizing useless stuff, but I'm telling you, it's very worth memorizing what units go with what. Are you seeing? It cuts down on your mistakes and you're thinking an awful lot. Helps you pick the right equation. So, by the way, here's what I'm saying. I just told you that we had a resistor, and we knew that it was an 18 ohm resistor. We measured the voltage with the voltmeter, 6 volts, and without having to go get an ammeter to measure current, you told me what it must be. It's actually pretty powerful. Let's keep going. Converting units. Ohm's law works with the units amps and voltage and ohms. The problem is, in the metric system, we also have prefixes like centi and milli and kilo and giga and penta and nano and micro. Those are the big ones. Sometimes if the readings are large, kilo is used in front of a unit. For example, kilo ohms would be a lowercase k with the ohms. A kilo is 1,000 of the original unit. So to convert kilo to standard units times by 1,000. Hey, is that on your yellow formula sheet? Someone look and tell me. Can you look and see where it is so that you know where to look if you blank out? Now, this one many of you know just because on the road we measure distances in kilometers, and often you've clued in that there's 1,000 meters in a kilometer. But if you blank out, it's there. To go from kilo to regular units, times by 1,000. Oh, and to go from regular units to kilo, divide by 1,000 because you're going backwards, but I don't know if I'm going to ask you to do that. Oh, so it's to convert, what did I say? To convert kilo to standard units. Sorry. Do you guys fill in the blanks? It's multiply by 1,000, I think is what I had you write. And 3,000 ohms is 3 kilo ohms. If the readings are small, milli is used. In fact, there's a bunch of voltmeters back there. There was 4 that looked just like the nice ones that we used, but I couldn't use them because they were measured in millivolts. Okay? Give me 1 second. The 2 main ones that we use, kilo for big stuff, but if they're small, we tend to use milli in front of a unit, which is a lowercase m, milliamps. In fact, 100 milliamps is considered, the milliamps are considered the death current. I think I mentioned that to you the other day. So a milli is 1/1000th of the original unit. So to go from milli to standard, you divide by 1,000. Did I put that on your formula sheet? I can't remember. Yeah? Can you look, so you know where it is? That's really, when I asked that, by the way, I do remember. I'm forcing you to glance at your formula sheet and having your eyes register where it is, right? So 400 milliamps would be 0.4 amps. 1 amp is 1,000 milliamps. 2 amps is 2,000 milliamps. So I will feel okay giving you some of these that you have to convert first. If readings are really large, say for a hydroelectric dam, which is putting out a lot of power, the prefix mega is used, capital M. Don't get capital M mega confused with little m milli. How can I remember that capital M mega is bigger than little m milli? Because it's a little m, lowercase m. Mega represents 1 million. So when you see 8 MV, it's times by 1,000,000. And I think I also put that in your sheet. Yeah? I gave you kilo, mega, and milli, right? So, here's the blanks that you can fill in. I gave you 3 blanks. When you see kilo, multiply by 1,000. When you see milli, divide by 1,000. When you see mega, multiply by 1,000,000, one with 6 zeros. Did I say that you're going to need a calculator for this? Yes. Okay. Although, timesing by 1,000 and 1,000,000, maybe you can do it in your head too, but you're going to want a calculator for the remainder of this unit. Trust me. Let's do an example. In a circuit, we have a resistor and it's labeled 400 M mousetrap hole symbol thingy. Oh, how would I read this in English? What does the lowercase m stand for? Milliohms. 400 milliohms, and the current is 3 kiloamps. Okay. What's this question asking me to find? Let's write down V equals question mark. Now we go scanning for numbers. The first number, when I start at the beginning, I run into is, what is the first number? Oh, this one. Kiana, what number is this, kiddo? 400. 400, what units next to it, folks? Is that resistance, current, or voltage? Okay, so let's write down R equals 400. Now it's milliohms. I can't leave it like that. I need to convert it. How do I convert it to just plain old ohms? Oh, okay. I'm going to write here divide by 1,000. Can someone do that, please? 400 divided by 1,000. I think it's 0.4, but double check me. It is 0.4 ohms. Now those units are acceptable. Keep reading. Riley, what's the next number you see in the question? 3. What are the units next to the 3? I see amps. So what is that 3? Voltage, current, or resistance? Current, symbol for current is I. And I'll write it down, 3Ka. How do I convert from kilo? Okay, Riley, in your head with no calculator, what's 3 times 1,000? Yes. And now, Nate, our units are okay. I'm looking for an equation that has a V and I and an R, and I'd like the V by itself. V equals I times R. This is Ohm's law. R times I is the same thing, but traditionally it's read V equals I times R. Riley, you gave us this. What's I? Yes. And Kiana, you gave us the other one. What's the resistance? Right here, 0.4. Yes! Sorry, boy, that was a growl and a half. Excuse the sore throat. 3,000 times 0.4, I think 120, double, yeah? 120 what? By the way, I made this up using legitimate numbers. What comes out of your plug is 120 volts. So, in case you're wondering. Although getting 3,000 amps from your plug is pretty tough. Turn the page! No, you guys, never mind. Next question. No, yeah, turn the page. I was right. Last little bit, and we're done. I might still be able to give you 20 minutes to work on the homework. Resistors. It turns out when you look at a resistor, there is color coding on the side of a resistor. In fact, when I showed you that comic a few minutes ago, these colored bands tell you how big that resistor is, what its ohmage is. And there's a chart. Here we go. Resistance is not futile. A resistor, I wrote, controls current and potential difference. Remember, can you underline this? Another word for potential difference is voltage within a circuit. And I told you last day the circuit symbol for a resistor was wavy lines, zigzag lines. It has bands of color on it that indicate the resistance and the accuracy. And if there is a fourth band, it represents the percentage accuracy indicated. Do you have to memorize this, or did I give this to you on your lovely little yellow formula chart sheet? I gave you the chart, and just below the chart, I think. Okay, so you ready? You guys have the chart in front of you, because I can't keep my resistor and this chart on the same screen, but you all have the chart in front of you. So, what would the resistance of this be? This is the procedure. The first digit is brown from the chart. What's the first digit of this resistor?
1.
The second digit is orange. What's orange? 3. And then the third band is what we call the multipliers. So put a times there. And it's times 10 to the power of whatever number red means. 10 to the 2? Red is 2. And then the accuracy, how accurate is this resistor? What's gold? Plus or minus what percent? It's a better made resistor. What's silver? It means the resistor is accurate to within 10%, because it's tough to make these. And what is it, bronze, the other one? No color means accurate to what? 20%. So that's the industry limit, is you're going to be accurate within 20%, but if you pay more for a silver banded resistor, it's a better component. If you pay even more for a gold banded resistor, it's better. What is 13 times 10 squared? Now you need to know where your exponent button is on your calculator. Or you can go 13 times 10 times 10, because that's what squared means. What is it? 1,300 ohms. And then it's plus or minus 5%. That's the resistance below. First digit, second digit, the third band tells you multiply by 10 to the what power? And then the fourth band, if there is one, tells you the accuracy. All of that on your yellow sheet. I'm definitely going to give you the worksheet, but let me look at the other ones. Let me pause the video for 1 second. Holy smokes, I am going to give you 20 minutes to work on the homework. Excellent. Didn't mean to make a marker there. Oops. We're going. Folks, look up. You can cross that off. Did I have this on your sheet as well for homework? You can cross off the reading check. Here, you can do these. It's only, I think it's 3 questions and 3 questions, or 4 questions and 4 questions. You can do these on the same piece of paper. All I'm going to ask is you DFIC, list your data, find a formula, insert the numbers, crunch the answer. Next day, or maybe the day after, depending on when I can get access to a computer lab, we're going to be doing some circuit building using a virtual circuit board on a computer. Folks, one last thing in your notes. I forgot to add this. At the very, very bottom of the last, or you know what? You guys got a whole half page of room right there. You can write the following. We measure voltage with a voltmeter. We measure current with an ammeter. It's almost amp meter, but we dropped the P because amp meter is trickier to say. Ammeter works. What are the units for resistance? What is resistance measured in? What are the units for resistance? Ohm. Well, it turns out we measure resistance with an ohm meter. Sorry, I spelled that wrong. Ohm meter. There's an H in there. I think in the homework they ask you what you use to measure these, and I think I forgot to include the word ohm meter in the notes. Now I'm shutting up. See if you can get it all done today. I think you can. I have no homework for the